It's very fortunate that my talk, not that it's the last talk, because there's drinks after this, which is also fortunate, but it's fortunate that my talk is after Kjetil's, because there's so many similarities in what he told you and what I am going to tell you. It's just that for me, it's about video, for us, and for Kjetil, it's about data, graphics, overlays and stuff. Things about interaction, synchronization, and also the use with monetization. So let's launch into this. I'm Rob. I'm from Tiledmedia, one of the founders. I'm just very curious. Who here has heard of Tiledmedia? Not too bad. Anyway, most people haven't. And interestingly, we do very high-end events, and they're usually such high-end that we can't mention the names officially. I always have a very hard time. We started as a VR company. We did multiple Olympics. We did Premier League with Sky, which we can mention, and with BT. We still do Premier League cricket in VR in India. We work with that supplier that Magnus uses every weekend. We also work with a dome operator that has like 30-meter screens, huge screens. They use our player technology. Anyway, today I want to talk about Multiview. And I think this, I could just basically go skip through quite quickly why it's relevant. I think Kjetil has made the case that it's very important to offer audiences interactivity, especially younger audiences. So I'll just skip through this. I'll give you a few examples. I'll give you a live demo at the end. It's a live streaming demo. But in general, there's a few use cases where multi-view is important. And multi-view is indeed not just switching cameras or having a picture-in-picture, but just being much more flexible. And it's about multi-camera events. It's about multi-game days, be it from the same sport or be it on a Sunday afternoon when there's a tennis match and a race and a football match going on at the same time, and you want to keep an eye on them, or you want to keep an eye on all your bets, for instance. So that's also why multi-view is important. Those are some of the examples. What's important is that it's personalized and customizable. Some of the multi-view technologies that are in use today have very fixed layouts. I'll get to that. But for a really good multi-view experience, it needs to be personalizable, customizable. So two different users have two different views of the same event because they have a different favorite rider, for instance. Another important use case, also touched upon by Kjetil, is doing ads in a way that it doesn't interrupt the programming. It adds to the programming, and you can find certainly with AI now, you can find good moments and good spots in the program where you could add personalized ads. And the good thing about doing this with multi-view is that what's hard with ads is that you have to stop one stream, seamlessly start another one, stop that stream, and then go back to the program. If you do it in multi-view, you don't have that problem because you just spin up a new stream, and when the ad is over, you just make it disappear again, and the program just continues. So it may even make it technically a bit easier. Now, multi-view is starting to gain some traction, and if you Google search multi-view, you'll get a lot of hits. YouTube TV is doing it, and they're expanding it even. They're making it, giving you more options. Apple is doing it also for MLS, and these are examples that are at least a year old. There are more. This Comcast has come on with Xfinity, is starting to do stuff. But there's a lot of solutions that I don't think cut it, and that's the heart of my talk, is I want to explain technically how you can do multi-view and what I believe and what we believe is the best way of doing it. So, it's hard. Great multi-view is hard. Either it scales well and it's not great, or it's a great experience and it doesn't really scale well. You have rigid interfaces, like you have a couple of quads where you can choose from a couple of quads if you're lucky. They're usually limited to 3, 4, if you're lucky, 5 streams, but certainly not across all devices, because not all devices have the same amount of decoders, for instance. There is some personalization, but it can be clunky. It can be hard to keep things in sync. And if you talk about the racing formats that we just discussed, it's really important to keep all the streams in sync. Also, when you switch, it must be seamless. The Formula One used to have, as an example, used to have a way to switch the camera, not to add the camera, but to switch the camera. And what would happen is you switch, you wait, you get the new feed, and you hear the same audio segment all over again, because it's not in sync. Or you jump ahead in time and you miss something important. So what happens is you don't use it anymore, because you know it's glitchy, and it takes you away from the storytelling. And that's also important. If you switch cameras, you switch away from the director cut, which is really stupid, because the director has a lot of great tools for telling you a great story. But sometimes you want to add your own story to that of the director. You don't want to replace it, you want to add to it. And that was my last point on the screen. So there's a couple of approaches. I will explain all of them, and I will explain what their downsides are. There are also some upsides, so I'll be honest about that. And these are the three. You can do many encodes, many different encodes. You can have multiple players on the client, and you can also do cloud or sometimes edge processing, edge encoding. So let's start with the first one, many encodes. This is what YouTube basically does. They figure out what are the most popular combinations of like 2 or 4 games, NFL games for instance. They mix them together at the server side, they do a single encode, and then they let you switch between that quad and other quads and maybe a full game. So that's one way. It's fairly easy to deploy or to build. It's also easy to deploy, and it scales really well in the distribution, because the distribution is really simple. Every user gets a single feed. It may consist of multiple feeds inside, but it's really one single stream. So it's easy to deploy. It's hard to seamlessly switch between these feeds. You can do it, but it's hard. And it also takes some buffering, because you throw away everything you have in the buffer. If you switch between like one quad and a full screen, you have to throw away everything you already had downloaded in your buffer. You have to start all over again, so this takes some time. So it makes it slow to switch. And it gets really hard. Take the example of Formula One again. I have 24 feeds. Now imagine all the possible combinations you could have with 2, 3, maybe 4 feeds. It's insane. So you either have to limit choice, or you have to have an insane encoding park running. So that doesn't really scale very well for these types of sports. Then another approach, this is the approach that Apple uses, is start multiple players on the client. It allows client-side interaction. You can basically do any combination that you wish, because any player can play any stream. They can have any stream. They can have any size. You can make ABR letters for them. So in distribution, it's fairly efficient, and it scales well as well. It's hard to deploy cross-device. If you're Apple, it's okay, because you control your hardware, and you know all of your devices can support maybe even up to 16 different players, because we've done some testing. But that's only on Apple. On other devices, you may only get 4 decoders, or maybe even 2. So you can only start 2. It's a nightmare to sync. And you can understand this, because each of these players think they're the only game in town, basically. They all have their own ABR engine. They all have their own buffer management. They don't know of each other, that they exist. So they're all greedy. And if the bandwidth is not like infinite, they start competing for bandwidth. One of them starts to buffer. They get out of sync, and this compounds. So it's really hard to do. Then there is edge cloud processing. This is what Screens does, for instance, and it's also Senza by Tiledmedia, if you know Senza. this very tiny set-top box that also relies on a cloud encoder per device. It optimizes the access bandwidth because you only need to stream that one single stream that's encoded in the cloud. It allows all the possible layouts and interaction if you have a flexible composition machine, but you need to have it, a flexible composition machine, for each and every user. And now this is okay if you say like, okay, I use it for my set-top box UI. Every now and then I want to switch channels, I have a nice layout, it's cloud generated, I switch a channel, and I go back to just a transport stream or a multicast. And my cloud encoder can be reassigned to another user. But if you want to do this for a race, you have to keep this cloud encoder alive for the entire duration of the race. So this is insanely expensive to scale to hundreds, thousands of millions of users. And depending on the technology that's used, the interaction may also be sluggish. It requires real-time encoding, obviously, which also, and I don't even have this here, but it's not good for the quality of the stream, the quality bitrate trade-off. So then, so there's another option, which is the one that's used with the racing format, which is single-player multiview. And in this incarnation, there is one single player that retrieves all of the streams that the user wants to use at the bit rates that the user wants to use them, or at the size that the user wants to use them, and then manages those streams and puts them on the screen. And in the most advanced form, which I will now talk about, which is the form that's used on mobile devices, it uses a single decoder. And the trick here is that this player retrieves all these feeds, and they're encoded using a little bit of encoded using HEVC with a few settings enabled, and these settings allow us to rewrite all of these little bit streams, these partial bit streams, into a single bit stream. So these are all legal HEVC bit streams. You could play them in VLC. We rewrite this. We rewrite this using, we write the headers, we don't touch the content itself, which is important because that makes it compatible with DRM. But we rewrite this bit stream, it becomes one large bit stream, basically. It goes through a single decoder, and then what comes out of the decoder is a large texture with all of these little feeds, and you put them in the right place on the screen, and you can have any layout you want, basically. So, the advantage is that you just encode for all of these feeds, you encode your ABR letters. It doesn't change whether you want to be able to switch to a single stream or whether you want to do a multi-view. And the good thing is that the player is aware of everything that's going on. There's one single engine that manages all the buffers and that manages all the ABR. If bandwidth goes down, you can manage the bandwidth across all your streams. You can make them all go down a little bit. And as you will understand, this is from a distribution perspective, this is really scalable. Just regular encoding, a few settings in the encoder that allow bit streams to be merged. This has to do with like headers and some motion vector constraints that are really simple. And then it can be done. So Elemental implemented this, and it's running in Media Live. ATEM is also does have the principles running. So we did some tests with ATEM. It's not hard. So the advantages, I think I touched upon them, but let's put them on one page. It's not limited to 4 feeds. I'll show you a demo with 25. Each user has complete freedom over their own layout. This is really important because of the bitstream rewriting the principles. We can't just guarantee that it's in absolute sync. It has to be in sync. If it's not in sync, we cannot rewrite the bitstream accurately. So it has to be in sync. And the switching is really fast. Like, for instance, if I want to make this the main feed, what happens, I click on this, I will show it to you in a bit, it scales up, it starts retrieving a higher resolution, This one is being scaled down, is being stopped, this stream. And then after maybe a segment maximum, you get high resolution imagery here, and it's all completely seamless and continuous, and you can't even hear audio switches. And yeah, it's scalable. So it's an overview. I'll skip over this a little bit. There's one bit of a downside, which is doing it cross-device. This is harder than with some of the other approaches. It's certainly not harder than with many decoders, but it's harder because this bitstream rewriting magic is difficult on some of the connected devices. So there's another mode that I won't tell you about today, which is still a single engine, which we use on the web, and it spawns multiple MSC, handles MSC players. But there's still and all of these little MSC players, they think they're the only game in town. They get fed only one ABR level. We tell them that the player basically tells them there's only one ABR level, and there's a proxy in the player, in the web player, that manages all this. It still manages all the ABR and all the buffer management. So I still have a bit of time to dive into the technology. I know Magnus is going to like this. So this is a high-level overview of the player. Like I said, there's a single network stack that manages these ABR levels and the buffers. There's a strategy model that feeds the network stack, tells it what to do. Then there's the bitstream rewriting. One bitstream goes to the hardware decoder, comes back, does the rendering. There's analytics, there's playout logic, there's a little bit of visibility calculation. This originates from our VR past, because if you're a headset, you need to calculate which of the tiles, we do that in Tiles 2, which of the tiles are visible. But it also manages the calculation of all the little feeds on the screen and how large they are. So now let's take an example. This is the last bit of my presentation, is walk you through it. A streaming example from basically working backwards from what you see to what is encoded. So these are all little feeds. There are 25 of them. There's a small pip, there's a large pip, and there's a main feed. This is what you see in the UI. This is what is streamed. This is why we're called Tiledmedia, because we use tiled encoding. And as you will notice, all of these tiles have the same size, which makes them mergeable in the HAVC decoder, in the hardware HAVC decoder in the device. So let's say the large feed has 9 tiles. The big pip has 4 tiles. The small pip has 1 tile. And we do an optimization step for the really small feeds, which is optional, where we sometimes combine the small pips or the small thumbnails. They're moving thumbnails. They're still videos. They're not JPEGs, but the small thumbnails, we merge them together for more efficient streaming. This is what goes through the decoder. So all of these are merged. They become one large image that's being decoded, and you can recognize the individual streams in it. And here are the small thumbnails. And this is what's being encoded. So you see there's, for each feed, this is a bit of a hypothetical example, but let's say there are 3 ABR levels with 9 tiles. In this case, there are 3 with 4 tiles. It's probably a bit many, but you get the point. There are 3 with 1 tile, and then there are a few for the thumbnails as well. So this all gets encoded. There is, all of these streams have their own manifests. There is also a meta manifest. It's one manifest that points to all of the individual manifests and that tells the player, okay, these feeds are available at these resolutions, and go have fun, determine which is the best combination to choose, given the bandwidth, given the screen size, given the decoder capacity, and given what the user wants to do on the screen. So let's now switch to a real-world example. Yes. Can we switch to the tablet? Okay, so this is what it looks like. And this is actually streaming, so it's not a local demo or anything. This is streaming. So I have 25 feeds, and I'll do this. I'll click on this thing, so it switches. You see it first switches, and then it scales up. And you also see there's a bit of bandwidth issue. You can do things like immediately switch to feeds, and it will actually switch around the streams that are being retrieved from the network. You can do stuff like this. You can make it larger, smaller. You can go overboard. There's really no limit to the amount of feeds you can retrieve, and these are all being retrieved individually, right? And you can still switch between them. You can do things like grids. Let's say. I picked the middle one, it scales up, and now I watch this program. And I have to say, we're not app builders, so we had to build this app to show the power of the technology. In the real-world app, it would look different. It probably wouldn't clutter the screen with all these pips, but you get the point. I'm trying to show the power of the streaming technology. But you can also do things like this. I want that pip there, I want this pip there, this is my favorite. And you can see how an operator could build a completely customized UI for this without having to have a cloud encoder, because the client would just learn what the favorite channels were, or the server would learn it, and would just retrieve those and make a customized, basically, UI with what's on the TV now. It's not a clunky EPG with out-of-date pictures, often wrong. It just shows you what is on TV right now. I thought there would be questions, but there are none. So thank you very much. It was a pleasure.